The cost function is given by this formula Cx equals 4000 plus 3x, where Cx is the total cost in dollars. In part A, we need to evaluate the average cost function. So average cost function is C bar of x is given by, we just divide the cost by the number of items, which is x. So that's 4000 plus 3x, that's given, divided by x. Now we separate into two fractions, so 4000 over x plus 3x over x. Okay, do not cancel, but 3x over x, then we can cancel x and x, just 3. So this is the average cost function. Now find the marginal average cost function. So marginal, this is the average cost function. So marginal average cost function means find the derivative of this function. So C bar prime x, marginal average cost function. Let's find the derivative. Derivative of 3 is 0, so we don't have to worry about second term. Derivative of 4000 over x is given by negative 4000 over x squared. How? Let me show you two different ways to find this derivative. So when we have 4000 over x and we are trying to find the derivative with respect to x, we can regard this as a fraction, quotient of two functions, and use the quotient rule. Using the quotient rule, on the bottom is square, I am using the quotient rule. Derivative of top is 0 times bottom x minus derivative of bottom times the top. 0 times x is just 0, so negative 4000 over x squared. That's what I wrote here, negative 4000 over x squared. Negative on the top, pull that one to the front. Or you can find the derivative of 4000 over x as follows. 4000 is in fact constant, and when we find the derivative of constant and a function, we can pull constant outside. That leaves 1 over x. 1 over x is same as x raised to negative 1. Now we want to find the derivative of 1 over x, which is x raised to negative 1. This is 4000 times xn. Derivative of xn is n x n minus 1, negative 1 minus 1, negative 2. And when we multiply and get rid of this negative exponent, 4000 times negative 1 is negative 4000. So I want to put negative in the front, over x to the negative 2. When we bring this to the bottom, then this negative is gone, so x squared. In either case, this is the marginal average cost function. Final.